Well, what up, everybody? I'm the math teacher Goat, and today in AP Precalculus land, we are doing a full lesson on section 1.2, rates of change. If you watched my last video on 1.1, I believe that was called Change in Tandem, you know that I am now doing full lessons of AP Precalculus on the old YouTube. So go to the description, download the PDF, waste your parents' printer money, and make sure that you have this and you can copy the notes and, follow along. So pause this and do that. Also like and subscribe and all that good stuff. I need that sweet, sweet, sweet YouTube money. So without further ado, let's get right into it. This is the warm-up that you should be expected to recall from the previous lesson. We have ourselves what looks like a cubic, and we have what looks to be, concave down, concave up. C would be an inflection point, so why don't I label that right there just for funsies. On what interval or intervals is my graph concave up? Well, if you are my inflection point, then you're going to be concave up from C to forever. So the way that we represent that in interval notation is we say C but not including C, and we say infinity but not including infinity. On what interval is the graph concave down? Well, it looks like all the way from the left to C, so we will say negative infinity with the parentheses to positive C with a parentheses. On what intervals is the graph increasing? That just means it's going up and to the right. So it looks like it's going up and to the right from A to B. It's not constant, but that's okay. It doesn't have to be as long as the Y values increase as the X values increase. And it looks like from D on, it's also increasing. So we're going to say from negative infinity to, what did I say, B? Now, we're not going to include B because technically at B, it's neither increasing nor decreasing. If we have more than one interval, we do the union symbol, and then we'll say from D on out. So D to infinity. Where is it decreasing? From B to D. So we'll just say B, D. We're not including either of those because we don't know if it's increasing or decreasing. In fact, we know it's not increasing nor is it decreasing, so don't include that. Find the zeros of the function, which means where is it crossing the x-axis? Just once, just at A. Just at A, so we'll say x equals A. And find the y-intercept. Well, that happens right here. When f of 0 is equal to e, your y-intercept is some arbitrary e. All right, so that's what we did in the last lesson. Now we're on this lesson. Very proud of what I did here. Very proud of what I did. Mr. Yeast is a YouTuber who specializes in bread-related challenges. Make sure you watch Mr. Yeast. He is very good. He tracked his subscriber amount over a 3-month span and found that he averaged a rate of that many subscribers per day in February, that many subscribers per day in March, and that many subscribers per day in April. Which month saw the greatest increase in subscribers? Well, we know that 30 days has September, April, June, and November, which means if we're talking about, what are we starting out with? February? February has 28 days. And so 28 days, and we'll put an F here for February. 28 days, he did 781.756. So we're going to multiply those together. For March is 31 days. And that was 708.387 subscribers. And for April, 30 days have September, April, June, and November. So there's 30 days in April. And that was 720.033. So what I'm going to do is I'm going to quick run off to the side and find out what these calculations are. When you see me again, you will notice that these numbers will pop on the screen. And we will find out what the total amount for each was. I'm back, and here are our numbers. So the question is, which month saw the greatest increase in subscribers? Well, we got 21,889, blah, 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 21,959, blah, 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 and 21,600. And the largest of these is March. Now, the trick behind this problem is you would look at the averages and be like, how is that even possible? That's 781 a day, and that's 708. Yeah, well, March wins because it has a few more days. So March is our guy. Okay. So the goal of today is dealing with average rate of change. And this kind of, we're starting out here by doing an introductory problem of averages. All right. Now the average rate of change by definition is going to be essentially the slope formula. I mean, if you were told that you have 2 points, right? So 2 points, let's say x sub 1, y sub 1, and x sub 2, y sub 2, you're going to use the slope formula, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And what the average rate of change is the slope between these 2 points. Okay, now when we're talking about rates, okay, so if I have a point here and a point here, and let's just say I make up some arbitrary problem where, like, I'm selling ice cream, and on day 2 I sell that much ice cream, and on day 5 I sell that much ice cream. I sell a little bit more. And I don't care about day 3. I don't care about day 4. I mean, I might be up here. I might be down there. It doesn't really matter. The average rate of change from 2 to 5 is going to be the slope connecting these 2 points. Now, this is Algebra 2 and Algebra 1. Algebra 2 and Algebra 1, oh, they're great. But now we are dealing with interval notation, right? So I would say between these 2 points, A and f of A, and points B and f of B, it's going to follow the same exact rules. The average rate of change, or AROC, which used to be a rap name for me, is going to be f of B minus f of A over B minus A. Okay, so we are going to use this formula more often than not because that's what it should look like here now that we're in AP Precalculus. All right, now, of course, this is F. These are D's and T's, and that's F's and whatevers. The same rules are going to apply. What is the average rate of change on the interval from 13 to 25 seconds? Well, the T, which would be like my X value here, is going to be from 13 to 25. So I will label you A, and I will label you B. Okay. My distance measured, my D of T, is basically the same as my F of A and my f of b. Okay, so to complete this problem, what we would do is we would say f of b, which is 30, minus f of a, which is 76, so we're going to have a negative here, over b, which is 25, minus 13, because that's our a. 30 minus 46 is negative 46. 25 minus 13 is 12. You can divide those both by 2, and that's about it. So that simplifies out to negative 23 over 6. Now, what this means is this is a rate. Okay, so you have time and you have distance. And we are saying, all right, well, the average rate of change is, since this is going to be the change in the D of T over the change in the T, is going to be meters per second. It's going to be distance per time. So whatever random problem this is, our average rate of change is we're slowing down at a rate of 23 meters per second. Okay, that is our average rate of change. All right. All right. Page 2. Find the average rate of change between 1, 2, and 3, 4. So 1, 2 is going to live right here. 3, 4 here. And the average rate of change represents, and bear with me here because it's not going to look that great. It's going to represent the straight line slope from one point to the other. Okay, so keep in mind, this is concave down, which means the rate of change is decreasing. Okay, so the rate of change is decreasing. So right now we're kind of at its fastest, and this is starting to slow down pretty significantly. I need to find the average rate of change for that. Okay, so I already have this is my formula. The nice thing about this formula is I don't have to plug anything in. I already have my points. You would be A and f of A, and you would be B and f of B. If I wasn't given these points, what I would do is, if it said find the average rate of change between 1 and 3, what I would do is plug it into this formula, and I would get 2 and 4, respectively. But since I have the points, writing out that formula, kind of useless. Kind of useless. So, average rate of change is going to be f of b minus f of a over b minus a. Based on what I chose, f of b is 4, minus f of a is 2, over b, which is 3, minus a, which is 1. Last time I checked, 4 minus 2 is 2, and 3 minus 1 is 2, and 2 divided by 2 is 1. So that straight line has a distance of, has a slope of 1, a perfect slope of 1. Now, this doesn't represent a real-life object, but what this would mean is this is changing at a rate of 1 unit, so it goes up 1y as it goes over 1x. Okay? That is what the average rate of change in this fake problem means. Okay? Now we have a table. Let's scooch this in. Hopefully I didn't cut anything off when I did that before. I have a feeling I may have. That's all right. What is the average rate of change on the interval from 21 to 102? All right. Well, I care about 21 to 102, so you would be my A and you would be my B, which means you would be my f of A and you would be my f of B. So f of B minus f of A over b minus a is my formula. F of b is 28. F of a is 1. B is 102. A is 21. 28 minus 1 is 7. 102 minus 20. Wait, not 7. 27. Duh. 102 minus 21 is 81. Not the same. And those are both divisible by 27, so you're a third. You are a third. You are. All right. This is where it gets kind of gross. And this is going to require some calculators. So, if you have a calculator handy, get ready to do it. Instantaneous rate of change is also known as just flat out rate of change, is the rate at a point. Okay? It's the rate at a point. So what we did is we found the rate between 2 points. Now we want a rate at 1 point. Well, how can I do this? How can I pull that off? I mean, I can't use the slope formula for 1 point. You're right. So this is what I'm going to do. I'm going to use the same exact formula, but instead of choosing 1, I am going to choose like an a value. So if I was thinking f of b minus f of a over a minus b minus a, I'm going to let a be a number just smaller than this, like 0.99. And I'm going to let b equal a number just bigger than this, like 1.001. So I can use the formula f of b, which is going to be 1.001, minus f of a, which is going to be 0.99. But here's the trouble. I need to find out what these are. I'll get there. 1.001 minus 9.999. So I'm going to use a calculator to find out what f of 1.001 is. How many woes? How many? Just one. How many woes? Vicky. I wonder how she's doing. I'll find out what that is. F of 0.999. We're going to find out what that is using a calculator. So essentially we take that, we plug it in. 3 times 1.001 squared minus 1. And we're going to do 3 times 0.999 squared minus 1. Okay, so we're going to use a calculator for this. All right, so let's do some math. 3 times 1.001 squared, I believe it was. There you is. Minus 1 ends up being that number right there, 2.006. Since this is AP Pre-Calc, we'll only do 3 decimal places. And then we have 3 times 0.999, 0.999, close it, square it, minus 1, and we end up with 1.994003. Now I know what I'm going to have to do next is subtract these guys. So let's quick do that, rounding where we have to. 2.006 minus 1.994. And then what we're going to do is take that number, and since our interval was, we'll find out, what was that interval? It was 1.001 minus 0.999. Okay. And so we need to divide these two numbers together. So 0.012 divided by 0.002, and that's going to give us an average rate of change at 6. So let's go back and do all that. That was probably a lot of calculator stuff, but that's okay. We'll go back and I'll try to make sense of it a little bit better than I probably did here. All right, so let's figure out what we came up with. Some pretty unpleasant numbers. We found out that U ended up being 2.006, blah, 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 but we'll leave it at that. And U ended up being 1.994, blah, 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 but we'll leave it at that. So that meant that we had 2.006 minus 1.994 divided by 1.001 minus 0.999. Now, we found out that this top part ended up being 0.012, and this bottom part ended up being 0.002, and when we divided these numbers together, we got a nice 6. Okay? So that is the instantaneous rate of change, what we think it is. What that means is if I were to graph this guy, okay, and if I were to graph this guy, which is going to be a parabola that looks like that, right at x equals 1, we see a slope that is very steep and looks like it would be a straight line of 6. Now, this has very, 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 very calculus implications. Okay, so you will deal with instantaneous rate of change a lot in calculus. It's called derivative. But that's what we're doing right now. That's what we're doing right here. Let's see if we can get away with this guy without the use of a calculator. We'll do a little bit less than 4, so 3.999. We'll do a little bit more than 4, so 4.001. And so we need to find G of B, which is G of 4.001, minus G of 3.999, all over 4.001 minus 3.999, which based on the last problem, we know what that bottom part's going to be. It's going to be 0.002. But let's find out what G of 4.001 is. Okay, we would do 3 over 4.001 minus 5, which is going to be 3 over negative 0.999. And that's going to be negative 3.003. If we do G of 3.999 over 3 over 3.999 minus 5, you're looking at 3 over negative 4.001. Sorry, that should be a 4. That should be a 1. What am I thinking? What am I thinking? That will give us negative 2.997. So you will be negative 3.003 minus negative 2.997. And that ends up being negative 0.006 over regular 0.002, which is essentially just saying negative 6 divided by 2, which is going to be negative 3. Okay, so this is a rational function, and for whatever reason at 4, this appears to have a instantaneous slope at negative 3. Fun stuff, happy stuff. I don't like instantaneous rate of change because there's a little something called calculus that's going to make life a whole lot easier. So let's go back to find the average rate of change Again, so we are given 4 intervals, right? We have red, blue, green, and purple. So red's instantaneous rate of change is going to be the slope between the points of the interval. This slope appears to go up 1, 2, over 1, 2, which is a slope of 2 over 2, a slope of 1. For blue, it's going to be up 1, 2, 3, 4, 5, 6 over 1, 2, 6 over 2, simplifies out to 3. So the average rate of change for blue is 3. For green, it's flat, which means 0. Easy. I can handle that. And for purple here, we have a negative slope, and that goes down 1, 2, 3, 4, 5, 6 over 1, 2. So negative 6 over 2 is going to have that's not how you spell purple. That's how you spell purple. As an instantaneous rate of change at negative 3. Which interval has the higher average rate of change? How can you tell graphically? Well, the highest rate of change is blue. And how do you know? Because it's the steepest positive slope. It's the steepest positive slope. Okay? Now, if it were to ask the opposite, if it were to ask the smallest average rate of change, it would be purple. And you could tell that graphically because it's the negative steepest slope. Okay? Graphing. Find the total change in each interval. Okay? Well, in this interval, we're going from 0 to 2. Okay? We're going from 0 to 2, and that's an average rate of change of 5. All right? So you have 2 units with an average rate of change of 5. That means you're going to multiply 2 to 5 and get an average rate of, or a total rate of change of 10. So from 0 to 2, your slope is 5. That means you're going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 1, 2. From 2 to 3, that is 3 units of a change because 5 minus 2 is 3. If the average rate of change is negative 2, then you're going to have a total change of negative 6. For this, going from 5 to 8, you're going to have an interval of 3x units with an average rate of change being 4. So you're going to multiply 3 times 4 and have a total change of 12. So again, drawing this out is, I would go up 5 over 1, up 5 over 1, and that completes u. This would have me go down 2 over 1, down 2 over 1, down 2 over 1. And since it's 3 of them, that completes u. And this has me going... since it's 4, up 4 over 1, up 4 over 1, up 4 over 1, which means it changes up 4, up 4, up 4, a total of 12. So the largest total change is 12. The smallest total change is negative 6. You might see a problem like that, similar to something like that on a homework if your teacher gives you AP Classroom homework. All right, positive and negative rates of change. What do that mean? A positive rate of change indicates that as one quantity increases or decreases, the other quantity, as one quantity increases or decreases, the other quantity increases or decreases too. In that order. So as one quantity increases, the other quantity increases. As one quantity decreases, the other quantity decreases, in that order. A negative rate of change indicates that as one quantity increases, the other quantity decreases. That is a negative rate of change. Okay? Not negative average rate of change. Rate of change is a fancy word for slope. There's a huge difference between the two. A continuous function f is defined on the closed interval from negative 5 over here to 6 over here. For how many values of b, okay, given the fact that negative 5 is in between, b is in between negative 5 and 6, for how many values is the average rate of change on the interval equal to 0? Okay, give a reason for your answer. If we're going from b to 5, right, so here's 5. 5 exists right here. An average rate of change being 0 is a flat horizontal line. So I could draw a flat horizontal line here. So that happens when x equals 3. Is that it? Nope. If I go all the way over here, I can create another flat line from -4 to 5. So at -4, we create ourselves 2, or another average rate of change of 0. So is it asking for how many values of b? 2 values. And the reason why is from here you get a straight flat line, horizontal line, and from there you get a horizontal line as well. Horizontal lines everywhere. Okay, so let's wrap this puppy up. We got some practice problems to do, okay, on this back page and the final page here. Is it the final page? Yeah, it's the final page. I paused it and looked ahead. All right, so which interval appears to have the greatest average rate of change? Now, this is going to be a pain in the butt. Average rate of change means the slope between 2 points. The greatest average rate of change is going to be a positive slope between 2 points. So I can try to draw, and this is going to look absolutely awful, but I could try to draw a straight line from B to C. Maybe I won't. Maybe I'll use the fact that I do have technology here, and I will find myself some lines that I can use. So let me do that instead. There you are. This will be a whole lot better. All right. So if I were to go from A to B, it's going to be negative. I don't want you. So from B to C, I have a steep slope. Pretty steep slope. Okay. I'm going to duplicate this. From B to C, I have another positive slope. I'm sorry, from B to D, I have another positive slope. Let's duplicate this one more time. And from B to E, I get this slope right here. Okay. Now, are those my only options? No, because I can also make a positive slope from D to E. All right. Which of these three is going to be the greatest average rate of change? Well, we find that by seeing which one the steepest is, and the steepest one is going to be from B to C, so that's going to be our answer. B to D is close, okay, but that's really the only possible answer. All right, so let's clear these out. Delete, yes, and delete, yes, and delete, yes. All right. Now I want the smallest average rate of change. And it's going to be pretty obvious pretty quickly. Okay, I'm going to go from A to B. From A to B. And another possible option is from C to D. And actually another negative option is from A to D. Okay, so let's scooch that over there. Barely. A to E, I don't think so. C to E, very, very, very shallow, but I guess technically it's negative, so we can do it. But it's pretty obvious which is which. Okay, from C to E is barely anything. The steepest negative slope is going to be from A to B, so that's going to be our smallest average rate of change. Which interval or intervals appears to have an average rate of change of 0? I would say the only option is from A to C. A to C looks like it would create a nice flat line. Okay. If you have terrible eyes like I do, you might want to argue like A to E, but as we saw, C has like a slope. So I don't know. I'm going to go with A to C. That's the only one that appears to have what I want. Okay, so we'll go with that. All right, which point has the highest rate of change and why? Okay, so what you saw before is when we were looking at rate of change, that's the same as instantaneous rate of change. And so what you need to do is you need to look at the dot and try to imagine a line going through that. The best way to understand this is pretend this is a roller coaster. Which of these would the car be on its way up the hardest? Okay, so if this was a roller coaster car, it would look something like that right there, a negative steep slope. You are coming up to the very tippy top, so you're going to be a pretty flat positive. You are coming from the bottom, so you're going to be a pretty flat, for the most part, negative, and you're going to be a very steep positive because you would be a roller coaster car going up. So which point has the highest rate of change? D does, because that would create a roller coaster car that is moving up and to the right at the steepest. Which one has the smallest rate of change? A would, because that would appear to be a roller coaster car going down and to the right at its steepest with a negative slope. All right. So this is how we're going to end the day. Use the information in the table to find the average rate of change on the given interval. So let's do different colors here. And for all of them, we're going to do f of b minus f of a over b minus a. So for a, we're going from 1 to 20, which means you would be my f of a and you would be my f of b. Okay, so f of b minus f of a, f of b minus f of a would be 516 minus 20 over 20 minus 1. This gives me 496 over 19, which according to Siri is 26.105. All right, so that's how you do that first one. And the rest of these are very, very, very similar. From 5 to 12, I'll call you A, I'll call you B. By the way, if you're colorblind, I'm really sorry. F of A, F of B, that's going to be 205 minus 74 over 12 minus 5. So that's going to be 131 over 7, which according to Siri is 18.714. All right, let's round this guy out. We're doing from 5 to 20, so you're A and you're B, which means you're F of A and you're F of B in purple. So 516 minus 74 over 20 minus 5.
516.
So you are 442 divided by 15. Well, I did something stupid and paused the video and kept on going, so I'm going to redo this last minute quickly. I ended up with 29.467 for that average rate of change. So what you really ought to do is go to my YouTube, type out AP Precalculus 1.2, and you will find some of my random AP Precalculus example videos that'll help you understand the material a little bit better. So definitely do that. Watch all of them. Make sure you hit like and subscribe. Leave a comment how amazing I am and how thankful you are for me. And I'll see you in 1.3. Thanks for watching. Bye.